Hello, it's me, Bunton, with your Visual Functional Mathematics at Level 1, Section 2, Measuring. Today's lesson is Lesson 4 on 2D shapes, net planes, and elevations. Before we start, I just want to remind you that it's important now that you try to get your learning materials together. You need your exercise book, preferably with grid lines like the book we used when we were infants with the little squares. And then you need to have your ruler, your mathematical set with a ruler and writing facilities, preferably pencil. And I expect that by now you have your calculator, so I trust you to do that. And in addition to that, for lesson 5, you will also be using your mathematical set, especially a protractor and a dividers and compasses. So expect that later on. So this is lesson 4 on 2D shapes, net planes, and elevations. We will cover the following: 2D shapes with or without lines of symmetry, the different types of triangles, types of quadrilaterals, properties of circles, the difference between flat and 3D objects, in other words, the difference between 2D and 3D objects, drawing nets from 3D shapes, objects and dimensions, and drawing accurate 2D and 3D shapes. The keywords you will be familiarizing yourself with are 2D shapes, 3D shapes, lines of symmetry, triangles, quadrilateral, circles, nets, planes, and elevation. The new words you'll be coming across are quadrilaterals, circles, nets, and planes. Because I think we touched on elevation in entry level 3. You need to know these words, know what they mean, and be able to apply them in maths. We'll start with 2D shapes. 2D shapes and lines of symmetry. What are 2D shapes? 2D shapes can have lines of symmetry or they cannot. Shapes with line of symmetry have two halves that are mirrored image of each other. In other words, when you fold them, what you see on one side, you see on the other. You could fold a shape along this line and the sides would fold exactly together. Some shapes have more than one line of symmetry, as you can see on the board. Okay, an isosceles triangle has one line of symmetry. The capital A has one line of symmetry, but a rectangle has two lines of symmetry, and a capital H also has two lines of symmetry. A square, can you think about how many lines of symmetry a square has? Let's find out later on. But first, some 2D shapes do not have any lines of symmetry, as you can see on the screen. Let's look at different shapes now. You got triangles. Let's look at family of shapes. Yeah? Triangles are three-sided shapes. They have different names depending on how many of their sides are the same length. Equilateral triangle has 3 equal sides and 3 equal angles. Each angle is 60 degrees. Equilateral triangle has 3 lines of symmetry, as you can see drawn on the diagram in front of you. Then you have isosceles triangles, which has 2 equal sides and a base which is not of the same size. The 2 angles at the base are equal, and it has 1 line of symmetry. I cannot tell you exactly the size of the angles because it depends on how wide or how narrow you make the base of the triangle. Triangles have different names depending on how many of the sides are the same length. You have scalene triangle. All sides are different lengths and all angles are different sizes. Scalenes don't have any line of symmetry. And then you've got right angled triangle. They can either be isosceles or scalene. When they are isosceles, that means at least two sides are equal. But then when they are scalene, all the sides are not equal. But right angled triangles have one right angle in it. Quadrilaterals, that's four-sided figures. They do not have to be squares or rectangles, but squares and rectangles are quadrilateral family. Let's look at other quadrilaterals. You can identify some of them by the number of parallel lines. Parallel sides are always exactly the same distance apart. They never meet. A perfect example is a railway track. And then you have rhombus, which is like a square that is squashed. All sides are the same length. Opposite sides are parallel and opposite angles are equal. It has two lines of symmetry. And then you have a parallelogram. Two pairs of equal parallel lines. Opposite angles are equal and it has no line of symmetry. That's the difference between parallelogram and a rhombus. Whereas a rhombus has two lines of symmetry, a parallelogram doesn't have any. Why? Because they are from a rectangle. Because they are from a rectangle, you cannot fold it to have mirrored sides. You also have kite, which has two pairs of equal sides, the top side and the lower side. I know kites very well. When I was a kid, we used to play with kites a lot. It has one pair of equal angles and one line of symmetry. You fold it longitudinally, you will have two mirrored sides. And then you have a trapezium, one pair of parallel sides, but no side is equal. Circles. The lengths in circles have special names. A circle is a continuum, so the perimeter or the line outside is continuous. But then a line that divides a circle into two equal bits is called the diameter. The diameter is the distance from one side to the other, passing through the circle. So no matter where you turn it, it's the same distance. And then you have a radius, which is half of the diameter. The radius links the center of the circle to any part of the circle. And the circumference of the circle is the perimeter of the circle. When you talk about circumference, that's the distance round. If you take a pair of compasses, if you've got your geometry set with you, try to draw a circle, put a pencil on it and stick it in the middle of it and just spin it around and you'll have a perfect circle. Practice question set 1. Question 1. Draw the line or lines of symmetry on the shapes below. Use your squared line paper and you can reproduce that and draw it. It's very easy. Question 2. Complete the shapes below so they are symmetrical in the lines of symmetry shown. Question 3. Jody is designing a logo in the shape of a circle shown on the right. The perimeter of the logo is 9.42 centimeters. What is the circumference of Jody's logo? What is the diameter of Jody's logo? Practice question 5. Padma has bought a new rug in the shape of a trapezium. The org has no lines of symmetry. Exactly two of the shapes are each 2 meters long. It has two right angles. Draw the diagram on the grid of what the shape of the org might look like. And these are your answers. Okay? So you can look at it. If you got it, it's very likely that you'll make some mistakes on these particular practice questions. But don't be put off by it. Just attempt it and then you correct yourself. By the time we finish, you'll be more confident. Question 3, you have to give figures. So it's 9.42 centimeters. And question 3b is 3 centimeters. Nets, planes, and elevations. Let's look what these are. Objects and dimensions. Some objects are flat. Flat objects, as we know, are two-dimensional or 2D objects. Some objects are solid. Solid objects are called 3D objects because they are three-dimensional, length times width times height, but not always the same because some objects have got funny shapes. However, you understand what I'm trying to say. The dimension of an object tells you its size. This box is 4 centimeters wide, 5 centimeters high, and 6 centimeters deep. The dimension of the box are 10 centimeters by 5 centimeters by 6 centimeters. This can also be written as 4 centimeters times 5 centimeters times 6 centimeters. This is about how you describe the object. And you can see below the description of each of the terminologies we've used. 2D means two-dimensional. So 2D objects have 2 dimensions, width and height. That's the dimension. What does 3D objects have? Yep, they have 3 dimensions, which is width, height, and depth. You need to be able to draw nets. What are nets? Simply, you have a 3D object, you split it up, open it flat, because most 3D objects could be open up flat. In fact, the most practical example now is what you call flat pack buildings, because they are all built flat with joints and stuff, with direction, and then you can put them together. A net is just a 3D shape folded out flat. You can use a net to help you make a 3D object, as I said. The net for cubes and boxes can easily be shown in the same basic shape. You need to be able to draw nets, and the cube has 6 sides or 6 faces. So the net of the cube has 6 squares. Okay? You know that a cube is equal all sides, equal angles, equals width, equal length. You have a 7 by 7 centimeter cube. It can be divided into 6 sides. All of the sides are of the same area or the same dimension. So each face of the cube is 7 centimeter wide and 7 centimeter high. So each square in the net is also 7 centimeter wide and 7 centimeter high. Let's look a little bit further. The faces of a cuboid are all rectangles. So the net will be made up from rectangles. Look at the dimensions of the cuboid to work out the dimensions of the faces. So you have 11 by 5 by 7 centimeters. So you can draw a net of this box. Now let's look at some instructions here. The box has 6 faces, so the net for the box will be made up of 6 rectangles. Draw the rectangles for the bottom of the box first. The diagram tells you it should be 11 centimeters by 7 centimeters. Next, draw the rectangles for the side of the box. The side should be 11 centimeters long and 5 centimeters wide. Now draw the rectangles for the front and back of the box. This should be 5 centimeters long and 7 centimeters wide. Finally, draw the top of the box. The top of the box should be the same length and width as the bottom of the box. And there you have it. This box should end up looking something like what you see on the right. Study it carefully and see if you can attempt it. If you ordered some stuff which comes in boxes, you can cut them up and see what you get. It's good practice. You have practice questions. And question 1. A cube is shown below. Sketch a net for the cube in your notebook or a sketch pad. Your sketch does not need to be full size, but you should be able to label it properly. Practice set 2. Question 2. Look at the box below. Draw a net for the box on the grid-lined paper or sketch pad similar to this one. The key is 1 square is equal to 1 centimeter. Label the dimensions and then see if you can draw a net of these cuboid, which should be rectangles really. And there's a solution for question 1 and there's a solution for question 2. Planes and elevations are 2D drawings of 3D shapes. You might be asked to draw accurate 2D drawings of 3D objects. How you draw them depends on where you looked at the object. You've got 3 views. If you look at the object directly from above, the drawing is called the plane because it's on like a bird's eye view. You only see 2-dimensional shape of the object. If you're looking at it from the front, it's called the front elevation or front view because there you'll be able to appreciate that it's 3-dimensional and it's not flat. So it's called the elevation. If you look at it from the side, it's called the side elevation or the side view. And there's an example of what we're talking about. You see the plane, that is from the top, front elevation and the side elevation. Make note of those words. Example of 2D drawings of 3D shapes. Draw the plane, the front elevation and the side elevation of the object on the right. 1 square of the grid is equal to 1 meter in real life. Start with the plane. If you look down on the object from above, it just looks like the rectangle because you do not see any elevation. It is 4 meters wide and 5 meters long. So this is 4 meters wide and 5 squares long on the grid. There is a change in the height of shape 2 along its width. Show this by drawing a line on your plane. The front of the elevation will be an L shape. It is 4 squares wide, 4 squares high on the left and 2 squares high on the right, as you can see on the front elevation. The side elevation will be another rectangle. It is 5 squares wide and 4 squares high. The width of the shape changes 2 meters up its height. So show this by drawing a line on the diagram. Your drawing needs to be accurate, so make sure you use a ruler and a sharp pencil. As you can see this, you begin to see how building something needs to be, first of all, designed using pen and pencil, a ruler to measure and to look at it from different perspectives, from the bird's eye, from the side elevation, the front elevation, and so on. Practice question set 3. Gwyn is planning to make a doll's house for his daughter. A sketch of the doll's house is shown on the right. Front elevation and side elevation on the doll's house. Draw an accurate plane front elevation and side elevation of the doll's house. You've got 3 squares, so use 3 pages or maybe divide a page in your exercise book and see if you can do the 3 different views. Okay? And these are the solutions. And that's your lesson for today. Remember to make notes of everything you've learned. Try to do it mentally first, and then you check the video again so that you can compare the notes you've made with my summary here. If I missed anything, well, you know you've got more recall than I have. But seriously, if you missed anything, you can always make your amendment to your lesson summary. That's important because the lesson summary will direct you to what you know and what you don't know. Okay, so this is mine. You now know that 2D shapes have one or more lines of symmetry. You also know that not all 2D shapes have lines of symmetry. You know the different types of triangles, and you know the different types of quadrilaterals, and that quadrilateral means 4-sided shapes. You know the properties of a circle and the difference between flat 2D and 3D objects. You know how to draw nets of 3D shapes. And then you know that nets are used to represent planes of 3D objects. And most importantly, what this lesson is introducing you to is that to design any physical 3D object, like maybe a house, a car, or any other structure, you need to plan it first. And the starting point is to design or draw the planes, label them accurately before you go to the drawing board, and finally before you procure your equipment when you're happy with them. This is what architects use, this is what building engineers use, this is what car designers use, and this is the start. The only difference is they have software to support them. So that's it for today. Remember to get your drawing materials, your mathematical set with a protractor, a compass, a divider, your ruler, and pencil. Get your exercise book if you have not done so before. And of course, by now I expect you to have your calculators and all the other materials you're supposed to have. That's our lesson. I hope you enjoyed it, and I'm looking forward to next week